So when we have a horizontal ellipse, it's long in which direction? Justin? The x, okay? It's long in the x direction. And the equation of a horizontal ellipse is going to be the quantity of x minus h squared over a squared plus, this is new, the quantity of y minus k squared over b squared equals 1. So I'm going to put a little star. We're going to say long in the x direction. So in a horizontal ellipse is long in the x direction, and I'm going to put a different star. I'm going to say a squared is greater than b squared. Okay, a couple of things I want to point out. So this is sort of our standard form of an ellipse. Just like the standard form of a circle is x minus h squared plus y minus k squared equals r squared. That's sort of like the formula. This is the standard form of an ellipse. Another thing I want to point out, notice how there's no number in front of the parentheses. We cannot have a number in front of the parentheses that's not 1. The only number that can be in front of those parentheses is a 1. Same thing for a circle. The only number that can be in front of the parentheses for a circle also is 1. All right, so this is a horizontal ellipse. Let's talk about a vertical ellipse. So for a vertical ellipse, we're going to have the quantity of x minus h squared over b squared plus the quantity of y minus k squared over a squared equals 1. And I'm going to put a star. I'm going to say long in the y direction. And I'm going to put another star and say that a squared is still greater than b squared. Since a squared is always greater than b squared, the bigger number will always be under the direction we're long in. So for a horizontal ellipse, the bigger number will be under the x, and in a vertical ellipse, the bigger number is going to be under the y. So the bigger number is always under whatever we're long in. So if we're long in the x, the bigger number will be under the x. If we're long in the y, then the bigger number is going to be under the y. A couple of other things I want to talk about. Let me get a little diagram going here. Okay, so the major axis is the length we're long in. So here, the major axis is the x-axis, right? Because we're long in the x. Now, we can find the length of the major axis. The length of the major axis is the length that we're long in from one vertex to the other. So this is called length of major axis. And that's always going to be represented by 2a. And that's from vertex to vertex. Okay, now if the length of the major axis is 2a, I'm going to throw in a new vocab word here. I'm going to say the length of the semi-major axis. And so think of the word semi. What is a semicircle? Half of a circle, right? So the word semi means half. So the length of the semi-major axis is going to be half the major axis. So if the length of the major axis is 2a, the length of the semi-major axis has to be a. And what that length is, it represents the length from the center of the ellipse to a vertex. All right, let's keep going. So now we talked about the major axis. Now let's talk about the length of the minor axis. The length of the minor axis is going to be represented by 2b. And the major axis is where the parabola is long in. The minor axis is where the parabola is short in. So for this specific one, because we're a horizontal one, we're short in the y. So from here to here, that is our minor axis from vertex to vertex. And then we're going to have the length of the semi-minor axis. So if the length of the minor axis is 2b, we already said semi means half, right? So what is the length of the semi-minor axis going to be represented by? Just b. And in the graph, what do you think that represents? The distance from what to what? The center to one of the minor vertices. Now that's going to bring us to the last thing I want to talk about, which is the focal length. And just to recap, because it was the last thing we talked about last class, the focal length is going to be the distance from one focus or one focal point to the center. And that's going to be C equals the square root of a squared minus b squared. And this is everything about an ellipse that we need to know. Do you guys want me to do all of this now for the vertical axis? I mean, a vertical parabola? Or are you guys able to switch it's really just switch the minor and the major for long instead of horizontal. We good with that? Everybody good with that? And even one person wants me to do it, I'll do it. Just let me know. Okay. No? Okay. So let's go from here. Oh, sorry. One more thing. The center point. What is the center point? Based on the equation. H comma K, just like a circle. So now it's everything. Okay, so now let's talk about a circle versus an ellipse. How do we distinguish a circle versus a parabola or an ellipse versus a parabola? How would I know this is either a circle or parabola or this is an ellipse or a parabola? How do we know that it's not a parabola, I should say? Justin. If I give you an equation.
Wait, no, the circle and the ellipse will have two squared.
Good. The circle and the ellipse will have both x squared and y squared, where a parabola will only have one of them squared. So now let's say, how are we going to figure out if I give you something, is this an ellipse or is this a circle? How would we know if they're both supposed to be squared? Well, let's talk about the equation of a circle. An equation of a circle is the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. Do we agree? All right, an ellipse, I'll just use a horizontal ellipse because it doesn't really matter. It's going to be the quantity of x minus h squared over a squared plus y minus k squared over b squared equals 1. So these are our two equations in standard form. And right now, the biggest difference I see that's standing out to me is that in a circle, it equals r squared, and in an ellipse, it equals the number 1. Can I manipulate the circle to make it equal 1 without changing its value? Absolutely. As long, and we know this based on the rules of algebra, as long as what I do to one side, I do to the other side, it's keeping it the same, right? So right now, what can I do to make r squared 1? I can't subtract r squared, because if I subtract r squared, isn't that a 0? I don't want 0, I want it to be 1. Good. We're going to now divide by r squared to make it equal 1. When I divide by r squared, I need to divide every single term by r squared to keep this balanced. And guys, I said it before and I'll say it again, just because it's a pretty big thing. For both the circle and the ellipse, we are never allowed to have numbers in front of the parentheses. You can have denominators, but you cannot have like an a. You cannot have the coefficients in front of the parentheses or something to distribute in front of the parentheses other than the number 1. So now when I divide by r squared, this brings me to x minus h squared over r squared plus y minus k squared over r squared equals 1. Versus the ellipse, which is write it again, x minus h squared over a squared plus y minus k squared over b squared equals 1. So now I have them both sort of in the ellipse format. Tell me, how do they differ? Even
The ellipse has a squares denominators, but the circle has square.
So what does that mean for your a squared and your b squared?
A squared and b squared can go along where it has to be perspective of the same.
Yeah, what this is basically telling me is that in a circle, my minor and major axes, which are A and B, right? The A and B are my minor or my semi-minor major axes. My semi-minor major axes in a circle are the same. Where in ellipse, they are different. But it's more of like a rectangle square scenario, right? Because a rectangle fills all the properties, or sorry, because a square fills all the properties of a rectangle, isn't it considered a rectangle? This is the same idea. It's okay that in a circle, my minor, my semi-minor, major, and minor axes are the same. That's okay. So a circle is a type of an ellipse. It's just better. I'm just like you, ellipse. I'm just better because my semi-minor and major axes are the same, where yours are different. So a circle is always an ellipse. An ellipse is what in reference to a circle? Sometimes. An ellipse is sometimes a circle if its semi-minor and major axes are what? The same. If A and B are the same. So an ellipse is a circle if A and B are the same. A circle is always considered an ellipse. Yes, we good? Okay. So let's write this down. Basically what I said, let's summarize it into a quick little note. Star, a circle is a special case of an ellipse where the semi-minor and major axes are equal. Which basically means A is equal to B. Sorry, where the length of the semi-minor and major axes are equal. All right, let's do some sample problems. Are you ready for this? So guys, this is a sketch. Even though I have it on graph paper, I'm actually not counting the boxes. So I'm going to write the coordinates that I'm using so you know. So this is not me counting boxes. So use my coordinates that I'm labeling. Okay, so the two vertices I have labeled are the points 0, 6 and 0, -6. The center is 0, 0. And the two focal points are 0, 2 and 0, -2. So the first thing we need to do is we need to decide what kind of ellipse am I dealing with? Am I dealing with a vertical ellipse or a horizontal ellipse? And we don't go by the fact that it looks tall and skinny because I might not have drawn this to scale, right? But what I do have to go by is that, or remember, that the foci are always on the major axis. So because the foci are on the y, that means this has to be a vertical ellipse. So I'm going to write that down for us. Star foci are always on the major axis. So with that said, therefore, this is a vertical ellipse. So that's your first thing you have to figure out. Is this a vertical ellipse? Is this a horizontal ellipse? We've now identified it as a vertical ellipse. So now we know which formula to use. We are going to use the quantity of x minus h squared over b squared because we're long in the y and a is bigger than b. So we're going to put the b under the x plus the quantity of y minus k squared over a squared equals 1. I'm going to put one more star for us. Remember, a is greater than b. Now, in order for this equation to make sense to the reader, we need certain values. I need to know h, I need to know k, and I need a b squared and an a squared. Once I have h, k, b squared, a squared, then I sub in and my equation makes perfect sense. What is h comma k? 0, 0, which represents our what? Center. So we want to remember that the center is hk. So we know for us, the center for this is 0, 0. So now I'm going to plug that in. So are we good with with me writing x squared over b squared plus y squared over a squared equals 1? Okay. Now let's go. We need a and b. Still need to find those. Who remembers what a is? What is a? Amesh?
Distance between that that's too bad.
No, the sum of the distance from the from a vertice to the foci to the two different, the sum of those two is 2a, but that's really complicated trying to find the distance. So there's a quicker way to do this. Yeah, so 2a represents on the major axis one vertex to the other, right? That's a 2a. But to make it even quicker, isn't the length of the semi-major axis the length from the center to one of the main vertices or the vertices on the major axis? So now if my center is 0, 0 and one vertex is 0, 6 on that major axis, how many units is that? 6 units. So do we all agree that our A is equal to 6? So now we have x squared over b squared equals y squared, not over 6, over 36. Ooh, I wrote equals. Sorry, it should be plus. Equals 1. My diagram is not accurate. So am I able to count boxes to find B? No, my diagram is not accurate. It's not drawn to scale. I can't count boxes. I can't do that. So now I need to find another way to find B. The only other information we have are the foci, the coordinates of the foci, right? 0, 2 and 0, negative 2. Now we did have a formula that dealt with the foci and it was the focal length. If you guys remember, this was at the end of last class, we said to find the focal length, it's going to be C equals the square root of A squared minus B squared. And who remembers what is the actual focal length from what to what? What is the focal length from what to what? Tyler. You got it. The focal length is the distance from the focus to the center. So if my center is 0, 0 and one focus is 0, 2, how many units is that? 2. So what does that mean? C is equal to 2. So now what I'm going to do is I'm going to use A and C to solve for B. So I'm going to say 2 is equal to the square root of 36 minus B squared. I'm going to solve for B squared. So to undo a square root, what should I do? Square both sides. So we're going to have 4 is equal to 36 minus B squared. minus 36 on both sides. I'm going to have negative 32 is equal to negative b squared. So b squared is equal to a positive 32. Do I need to square root both sides? Good. Why do I not need to square root both sides? Good. We want b squared. We don't want b. So it's the b squared that's in the equation. So this is going to be x squared over 32 plus y squared over 36 is equal to 1. And so when it says write the equation of the ellipse represented in the diagram, this is the equation of the ellipse represented in the diagram. If I had wanted to, would this still be correct? Is that okay? Yeah. Why is this okay? Ilya? Good. Addition's commutative. So the x doesn't have to be first. With an ellipse, all that matters is that the bigger number is under the major, under where the major axis is. So because this is a vertical parabola, the bigger number has to be under the line. All right. Next one. So I'm asking us to find the foci and the length of the minor and major axes. First thing I'm asking you is find the foci. Did I say find the length? Or find the focal length, I should say. Am I asking you to find the focal length? No, I'm saying find the foci. What are the foci in the graph? 2 points. So when I'm saying find the foci, I'm not asking for the focal length. I'm asking for the coordinates of those foci, of the 2 foci. That's what I'm asking for. And then it's saying find the length of the minor and major axes. That's fine for us. How do we find the length of the minor axis? What is that represented by? Yep, 2b. What about the major? 2a. So we know the minor's 2b, we know the major's 2a. Now I'm going to look at my equation. Is this a good format? No. How do I know that it's not a good format for an ellipse, but also that this is not a circle? So for both of these, this is not a good format. It's not a good format for a circle. It's not a good format for an ellipse. Why? Helen? Good. There's a coefficient in front of the x squared. For both the circle and the ellipse, am I allowed to have a coefficient? Never. So what do I have to do to fix this? I'm going to treat it like an ellipse. I treat it like an ellipse until I know that it's a circle. Rihan? Good. To treat this like an ellipse, it needs to equal 1. So I'm going to divide everything by 16 and hope this takes care of everything. And so when I divide by 16, it does take care of everything because 4 goes into 16 4 times. So we have x squared over 4 plus y squared over 16 equals 1. Is this a circle or an ellipse, and how do you know? Omesh? Excellent. It's an ellipse because A and B are different. So now next question for you. Is this a vertical ellipse or a horizontal ellipse? Yeah. How do you know? Excellent. The larger numbers under Y, which means it is a vertical ellipse. So when I ask for the minor and major axes, I know A squared is 16, which means A is 4. I know B squared is 4, which means B is 2. So now the minor, the length of the minor axis is not B. What is the length of the minor axis? 2B. So if B is 2, 2B is 4. And the length of the major axis is going to be 2A, which is 8. That was the easy part. Now I need to find the coordinates of the foci. The only formula I have related to the foci is what? The focal length. But isn't that focal length the distance from the center to the two focal points? So if I find that length and I know the center, can I figure out the coordinates of the foci? So that's what I'm going to do. We know the focal length is equal to the square root of a squared minus b squared. And I have a and b, so this works. So we're going to have c is equal to the square root of 16 minus 4. So c is equal to the square root of 12. I must simplify all radicals, and the square root of 12 simplifies down to 2 root 3. What does this mean? That is not it's not just 2 root 3. I wasn't asking for the focal length. I was asking for the coordinates of the foci. So I'm going to go back to my equation. What's the center of this ellipse? 0, 0. And this is a vertical ellipse, right? Because the bigger number was under the y. And don't the foci lie on the major axis? So that means from the center on the major axis, the y, I have to go up 2 root 3. So this is going to be 0, 2 root 3. But then I also have to go down 2 root 3. So it's 0, negative 2 root 3. So when I ask for the coordinates of the foci, we're going to have 0, plus or minus 2 root 3. And here are all our answers. If you wanted to write it as 2 different coordinates, could you have? Of course. All right, next one. So do we all agree we need to make it look like x minus h squared over something plus y minus k squared over something equals 1? Clearly, this is not it. So what is that algebraic process that I'm going to have to take to make it look like that? Completing the square. Exactly. How am I going to complete the square? I'm going to group my x's and y's together, and any number that's not within x or y, I'm moving to the other side. So I'm going to group 2x squared minus 4x plus y squared plus 8y. And what am I going to do with that negative 6? Add it to the other side, so it becomes equals positive 6. Everybody okay so far with what I've done? Hey, I hope you guys remember this, but we can't complete the square with a leading coefficient. So when we have a leading coefficient, what we want to do is we want to pull it out like a GCF. So in my first parenthesis, I have that leading coefficient of 2 for that 2x squared. So I'm going to pull the 2 out like a GCF, and then I'm going to get x squared minus 2x plus y squared plus 8y equals 6. And now I'm going to continue the process of completing the square. So I'm going to work with the x's first. Half of 2 is 1. 1 squared is 1. So I'm adding a 1 inside my parentheses. But in reality, I'm not really adding 1 on the left side. Aren't I really in reality adding a 2 times 1 to the left side? So that's a 2. To keep this balanced, if I'm adding 2 to the left side, what do I have to do? Add 2 to the right side. So now this becomes 2 times the quantity of x minus 1 squared. Now let's complete the square for the y's. Half of 8 is 4. 4 squared is 16. I add 16 to the left. I add 16 to the right. So this becomes plus y plus 4 quantity squared equals 24. Is this good? No. What's wrong with it? Good. I have to divide by 24 for a couple of reasons. First reason is it doesn't equal 1, right? Doesn't an ellipse have to equal 1? The second thing is, am I allowed to have a leading coefficient of 2? No. So by me dividing by 24, doesn't it take care of all of that? So now I'm going to divide every single term by 24. And then once I do that, I end up with the quantity of x minus 1 squared over 12 plus the quantity of y plus 4 squared over 24 equals 1. Now, all I asked for in this problem was the equation of the ellipse in standard form, but just for fun, I'm going to ask for a couple more things. Can somebody tell me now by looking at this equation, what is the center point, Lucas? Excellent, 1, -4. What is the length of the major axis here? Well, what's a squared? Let's start there. What's a squared? 24. Wouldn't I have to square root both sides? So then when we simplify that, wouldn't that be 2 root 6? But that's a. The length of the major axis is not going to be just a. It's going to be 2a, which makes it what? 4 root 6. You got it. What about the length of the minor axis? You got it. Last problem. I'm sorry, guys. I know.
Wait, to find to the square root of a squared minus b squared, and then that would be like the distance
From the
that-
center.
to there, and if you have like to just like go up.
You would add it to the y coordinates and subtract from the y coordinates. Yep, you got it. Perfect. All right, guys, last one. It's going to be a graphing one. Okay, ready? What number is this? 4. So I want us to graph x plus 1 squared over 36 plus the quantity of y minus 2 squared over 9 equals 1. And I want us to include the center, the foci, and the different vertices. So include center, foci, vertices. So first question for you, is this horizontal or vertical? Horizontal. So because this is horizontal, do we all agree that a squared equals 36? So a is equal to 6. B squared equals 9, so b is equal to 3. The next thing I'm going to do is find my focal length. So c is equal to the square root of 36 minus 9. So c is equal to the square root of is it 27? Yeah. So that's 3 root 3. Is everybody okay with what I've done so far? Okay, what is the center of this graph? -1, comma 2. All right, guys, we are ready to actually graph this. Okay, so my center is the point -1, 2. And now we said this was a horizontal ellipse, right? So when I come, my A is going to go horizontal. So my semi-major axis length is 6. What does that mean? From my center point, I'm going to go 6 units to the left. And from my center point, I'm going to go 6 to the right. How am I going to use the B now? So I used A, left, right. How am I going to use B? Up, down, exactly. So my B is 3, so I can go 3 up and 3 down. Now, if I asked for the vertices, which I did, I want us to write out these 4 points, the coordinates for the 4 points. So our vertices are going to be, did anybody count what it is? We're at -1, 5. We're at -1, -1. We are at 1, 2, 3, 4, 5, 6, 7, -7, comma 2. And five, 2. Did I get those right? Okay. Those are the vertices. Hold on, guys. Then it wants us to name the center, which we already did. And the next thing we want are the coordinates for the foci. So in order to find the coordinates of the foci, what we're going to take is we're going to take the focal length. And now we have to remember the foci are always on the major axis. Which is the major axis this time, X or Y? X. So what do? We take those that focal length and add it to the X coordinate of the center. So this is going to be -1 plus 3 root 3, comma 2, and -1 minus 3 root 3, comma 2. Do you see how I found that? All right, now we are done. Oh yeah. No, I'll just ask for it. I won't make you plot it. We're good.